Okay, today we're doing trig lesson number 5 in geometry. The difference today in what we have been doing is we are going to solve for missing angles in this section. So for this one, we're going to use trig to solve for missing angles. Thus far, we've only been solving for missing sides, so we're going to solve for missing angles. So what we're going to use is inverses. So inverses, what are they? They are opposite operations. What do? They chunga things. The kind of more formal way to say that is that they undo the effects of the original operation. The key here is they undo, okay? So some examples of inverses are like addition and subtraction. Those undo one another. Multiplication and division, square root of x and x squared, those are inverses. The inverses that we're going to talk about today are inverse trig functions. So sine and sine inverse, that's how you write inverse sine with this little -1. Then we've got cosine and cosine inverse, as well as tangent and tangent inverse, okay? These operations undo one another. So we're going to do 3 examples, but before we do that, we'll look at what sine inverse looks like. So it says, we'll only do a couple of these. You can type them in your calculator if you want, but sine inverse of 0.8660 means that sine of some angle equaled 0.8660. So if we want to know this angle, what we have to do is sine inverse both sides, these chunga. So we know that A is equal to sine inverse of 0.8660. So if we type that into a calculator, to get the inverse sine key, you have to look right here. It's in blue above the sine key. So what we're going to do is hit the blue key first and then hit sine. Sine inverse will show up. If we do 0.8660, hit enter, it's 59.9971. So I'm going to round that up to 60 degrees. Okay, so this is 60 degrees. Now, if we do the same thing here, this means that sine of some other angle equaled 1/2. So maybe the original sides, who knows, maybe the original sides were like 15/30. Remember how we've been doing opposite divided by hypotenuse? Well, when you do opposite divided by hypotenuse, we get 0.5. So we need to inverse sine both sides. And we get angle B is equal to the inverse sine of 0.5. And if we do that, we get 30 degrees. Now, the inverses for tangent are the same. You just hit second tangent. Same with cosine. You hit second cosine. These numbers are going to come out as different values. I'm not going to spend time on the video, but I'd like you to type those in for these first 2 rows just to see the difference in the numbers, okay? So let's use it. In this problem, we are told that a, lowercase a, is equal to 24. So here's lowercase a. This side is 24. Then C is 25. So C is 25. They want us to find B and then find the angles. All right, well, let's start with finding B. Now what I notice is this is a multiple of 4 and this is a multiple of 5. You don't need to write this down, okay? You don't need to write this. But I noticed that this is 4 times 6 And this is, ooh, it's not going to work for us on this one. Okay, this one is 5 times 5. So since these are different numbers we multiplied by, it's not going to work. So we're going to have to go old school Pythagorean theorem on this one. So we've got 24 squared plus b squared equals 25 squared. So b squared equals 25 squared minus 24 squared. And then we need to square root both sides. So I'm just going to type into my calculator the square root of 25 squared minus 24 squared and hit enter. So that missing side is 7. Okay, b is 7. All right, now we need to find angles A and B. So to find angle A, so we're going to find angle A first. We need to go stand over at A. And then the two numbers we were given, the two sides we were given are the ones that we should really use. So in this case, that's the opposite. So we've got the opposite of A is 24. And then this is the hypotenuse, which is 25. So we want to use the sides we are given, because if we made a mistake here, we don't want to mess everything else up. So based on angle A, this one's our op, and this is our height. So O and H, that means sine. So we're going to use the sine of angle A is equal to the opposite over the hypotenuse. Okay? Just like usual. But now we need to inverse sine both sides. So we're going to go sine, inverse, chunga chunga. Angle A equals the inverse sine of 24 over 25. So in our calculator, we're going to go second inverse sine of 24 divided by 25. Hit enter. We're looking at about 73.74 degrees. Okay. In class, we'll talk about whether we should round it up to 73 or to 74, or if we want to keep it as a decimal. We can decide on that as a class. Okay. So this was to find angle A. Now to find angle B, we kind of have to start fresh. To find angle B, we're going to do the same thing where we circle our desired angle. So we're going to look for B in this one. If we look across, that's our opposite, but again, we want to use the numbers we were given. So we want to use 24 and 25. This would be our height. That's our op, so this is the adjacent. So we want to use our height, our hypotenuse, and our adjacent side, because those are the two we're given. Based on B, that's the hypotenuse, and that's the adjacent. So adjacent and hypotenuse is cosine. So we're going to say that the cosine of B is equal to the adjacent over the hypotenuse. This is where students get kind of messed up, because we're switching from angle A to angle B. So we're naming them differently, and that's where students struggle. So what we've got is cosine inverse. So we get B equals cosine inverse of 24 over 25. So about 16.26. Now, if you have stayed and listened to this whole thing, you're probably going to get annoyed with me, because what we could have done is after this point, we could have said, oh, okay, I know this is 73.74. We could do 180. So this is a secondary option. You could do 180 minus 90 because of